Okay, YouTube, in my last video we worked on how to multiply rational expressions, and in this video what we're going to be doing is essentially dividing with rational expressions, which comes really back to a simple property that allows us to rewrite quotients as products in the first place. So essentially this is going to be multiplying rational expressions again as soon as we rewrite it. So we're going to borrow this property that says when you divide two rational expressions, we have a over b divided by c over d, this will have the same value as if you were to take the value a over b and multiply by d over c. So what essentially we get here is a situation where we would just multiply these straight across, we get ad over bc. So when we look at these rational expressions, our technique is going to be really a whole lot the same on this here, where we're going to go ahead and factor everything first and rewrite things first and then multiply. We're going to use multiplication. So when we divide the following rational expressions and simplify where necessary, we notice that we have this first rational expression here. So I have 5x on top over 3x minus 12 here divided by x squared minus 2x divided by x squared minus 6x plus 8. Well, the first thing we want to do is this. We want to rewrite this expression so that we have 5x over 3x minus 12, and instead of dividing, we're going to multiply by, and what we'll multiply by here is the reciprocal of the dividend, or the divisor, sorry, the thing doing the dividing. So what we end up with here is this, and now what we're going to move on to is factoring any expressions that we can. So I notice 5x is pretty much as plain as that's going to get. 3x minus 12 does have a GCF, so 3, when we factor that out, we get left with an x minus 4. If we were to look at this, numerator expression here, we have a trinomial where a is 1. So can we think of two values, two integers that multiply out to be a positive 8, but they have to be a negative 6? And I'm thinking that this has to be negative 2 and negative 4. And down here we say x squared minus 2x. Those both have in common an x, so we get left with x minus 2. So this is as furthest down we could break these down. So what we want to do is, before we multiply these straight across, say, do we see any common factors we can reduce? So like 5 and 3, no. Here I don't see any straight up and down. Crosswise I could say, well, this x here and this x here, they cancel out. They're common factors. And then we say that this x minus 4 cancels out with this x minus 4, and this x minus 2 cancels out with this x minus 2. So we got 1, 1, and really, when it's all said and done, it looks like we're just left with 5/3. So what we started with right here, the answer to this is this thing right here goes into this thing right here 5/3 times, which is kind of a fun fact. So we're going to do this again. We're going to accomplish this task 2 more times. On this one here, notice that we're dividing a rational expression by what you would say like is a whole expression. And I guess what I want to point out there is basically we're going to have to interpret this as being over 1. Because when we rewrite this as multiplication by the reciprocal, what we're going to instead do is we're going to list this here. We've got 6x squared plus 7x plus 3. This trinomial over 6xx or 6x squared. We're going to rewrite this as 1 over 2x squared plus 3x. Okay, so before I move on from here, I do actually want to list this. Every once in a while, you'll run into what are called, like I guess people call them complex rational expressions. And I don't mean with complex values, but I mean like what they do is they tend to write like a fraction. This is 6x squared. And they say take all that, and divide it by 2x squared plus 3x. And I just want everybody to see that these two statements here, one listed laterally and the one listed vertically, these mean the same thing. We would still put this over 1, and we would take this top expression and multiply by the reciprocal of this bottom expression. So that having been said, let's go ahead and take a look at this. We want to factor both of these right here. I noticed that this one here, greatest common factor, just sticks out to me. So when I rewrite this, I'm going to go factor that one first there. It'd be 1, it looks like here, and we get, no, not 2, x. And so we get left with 2x plus 3, and down here I say 6x squared is pretty much 6x squared. Now this is a trinomial where a is not 1. So what this means is we're going to have to guess and check with our FOIL. Checking first for what can we multiply to get a 6x squared. So this would have to be a 2x and a 3x. And I'm just going to drop a little hint here. When you're simplifying rational expressions, at least when you get used to it with these types of exercises, what you're going to find a lot of the time are situations where your math teacher or a text has set it up so that things cancel out very well. So when I say, well, what are some factors of this? And I know that, it's got to be 2x and 3x probably in the front of these two binomials that we're foiling out to get this. I'm going to look down here in the bottom part of this rational expression and notice that there's a 2x plus 3 as one of my factors. So I'm suspicious that this might be plus 3 here. And I only say that because I think that maybe they'll try to set it up so that I'm practicing cancellation. So I'd say, can we think of two values now that multiply out to be not the 6x squared and put those in front, but the 3 in the back? I'd say 3 and 1. So let's try this out here. I got to check my outer and my inner, but I get, 2x times 1 is 2x, and then 3 times 3x, that's going to be 9x. So when I add those together, I get 11x. So I guess it wasn't this here in the middle. You know what I noticed? As a matter of fact, I've rewritten this incorrectly. This is a negative, looking back at the beginning. So that would make a difference here. That's going to make this a negative 1, and it's actually going to make our lives a lot easier. When we check this again, we get a negative 2x and a positive 9x. So when you add those together, we get 7x. So that would mean that we do get this expression here. So our factors are indeed 2x plus 3, as we kind of suspected, and 3x minus 1. So we're going to cancel out common factors now. Those cancel out, and it looks like if we now multiply straight across, I don't see any other common factors. We're just going to multiply the remaining things. So we say 3x minus 1 times 1 to itself. And we say 6x to the second times x to the first. This would be 6x cubed. And we would be able to be assured that this would be the simplest form expression. So really quickly, we're going to tear this one apart. We're going to say, let's put this over 1. We're going to do order of operations, which says work to left to right with multiplication and division. We're going to rewrite this first, though. So we would get x over x plus 5 times, I'm going to write 3x minus 5 over 1. And we're going to take this times now x plus 5. And this is over, now I notice this is a difference of two squares. We could say if it's a difference of squares, these are conjugates. I would get 3x squared times, 3x squared basically would give us 9x squared. And then if we were to take 5 times 5 or 5 squared, we get to 25. So let's cancel out some common factors. I notice across the board here the 3x minus 5 and this 3x minus 5 cancel out. And this x plus 5 cancels out with this x plus 5. And so I'm left with 1s in any of these spots where there was nothing left to keep its place. And so we would get x times 1 times 1. So on the top here we get x. On the bottom I get 1 times, 3x plus 5. 1 times 1 times 3x plus 5. We get 3x plus 5. So this would be our simplest form expression of this quotient. Cheers.